Analyze vertical asymptotes of rational functions. So our first question, we have h of x is equal to a polynomial over a polynomial. That polynomial, those two I have written down here. And the first thing we want to do is actually factor them so we can figure out more about this graph. I'm going to go look at the graph first. So here's the question. Then I have a graph right here. So what we're looking for is, well, actually, you didn't talk about the question yet, did I? So we're describe the behavior of the function h around its vertical asymptote at x equals -6. So they're already telling us where the asymptote is. And you can see where that asymptote is by looking at this. And we know the asymptote is, when we cancel these things out, this is our asymptote, what's in the denominator. So it would be x equals -6. So they give that to us, but we can also see that it is true right here. And then at -8, we're going to have a 0, is a 0. All right, so we'll go back to our graph and we'll see if that's what it looks like. And so here is our x-axis, and we can see at -8 we have a 0. And then right here at -6 we have a vertical asymptote. It goes up here forever, and it'll never ever cross -6. Zoom out, and it looks like a straight line. Even though it's not technically a straight line, it's very, very close to a straight line when you zoom all the way out. But we're going to zoom back in. And the question, this is probably good right here. So the question again. Describe the behavior of the function around its vertical asymptote at x equals -6. So the answers look very confusing. What we need to look at is as x approaches, that's what this arrow means, approaches -6 from the negative side. So as x approaches -6 from the negative side, that's what this. So this is the negative side, and we're approaching -6 from the negative side. Where does our graph go? Well, our graph goes down forever, so it's going to -infinity forever. -6 goes to -infinity, and then as x approaches -6 from the positive side, where does it go? It goes to positive infinity. Now these graphs could be flipped. And actually, I think if I just put a negative sign, no, that didn't work. They could be flipped upside down. It could be as x approaches -6 on the positive side, it goes down, and this could go up. But this case, as x approaches 6 on the positive side, it goes up, and as x approaches the as x approaches -6 on the negative side, it goes down to -infinity. So looking at our answers, we have -6 on the negative side is negative, so it's either going to be A or D. And then as x approaches -6 on the positive side, it's positive. So this is the correct answer, B, right here. Now, on a graph, on a test, you're not actually allowed to graph it, and there's a way to figure out the answer not by looking at a graph. So that's where we go back to this part. So we know we have a 0 at -8, and we have our vertical asymptote at -6. All right. So we want to make sure we list all the numbers out that we know in order. And you'll see this will happen differently in other problems. We had a lot of numbers crossed out here. So we're going to pick a number at -7. Then we're going to pick a number, on this side of -6. So one smaller, and then we're going to pick one bigger, if possible. If we had, let's say, a -5 up here, we would have to go -4.5. But right now, we can pick any number that's on this side. And we're going to just plug in the numbers. So -7. If I put in -7 up into our problem, we can do it in either of them. It'll turn out the same. So -7 plus 6 is -1. -7 plus 8 is +1. And then -7 plus 6, we already did that, it's -1 times -1. So all of these negatives, we have a negative times a positive, which is a negative. And the bottom is a negative times a negative, which is a positive. And then negative divided by positive is equal to a negative. So on this side of our -6, we're going down to -infinity. Then let's look on this side of -6 and where we're going to. It should be either negative number or positive number. We already know it's positive, so we should get a positive out of here. So -5 goes into the first part, x plus 6, we get a +1. -5 plus 8, we get a +3. And then -5 plus 6, we already know is a +1 times a +1. Well, we know everything up here is positive. So it's a +3. We are going to be going to positive infinity. One thing, all we care about right now is the sign. We don't really care about the number itself. Just because this is positive, we know it's going to positive infinity. We can get a number closer and closer to -6. Like if we put in -5 5.9999. It's going to be a number way, way larger than just what we have here is 3. Oh, sorry. So you look at the graph, as we get really, really close to our x-axis at to negative 6, see 5.934, it's 33. And as we go farther and farther up this number, or this graph, it gets to be a higher and higher number. Okay, so let's check our answer. We said it's B. And there you go. Next question. Once again, h of x is equal to a polynomial over a polynomial. First thing you want to do is factor these. So I've already done that. X squared plus 2x minus 24. The negative 4 times 6 is negative 24. 6 plus negative 4 equals positive 2. And then 5 times 5 is 25. And 5 plus 5 is 10. All right, so now we need to analyze this real fast. So nothing cancels out. So we don't have any discontinuities. But we do, remember I'm using this little cheat sheet. So nothing cancels, so no discontinuities. But we do have numerators. We have 2 of them, which means that those are zeros, and our denominator gives us our vertical asymptote, which we just have one vertical asymptote, which is negative 5. We'll just use VA, vertical asymptote. And then my blue will represent my zeros, negative 6 and positive 4 are my zeros. Now, what you want to do is put these in order on a number line. So our smallest number is negative 6, then negative 5, then positive 4. All right. So now when we select numbers to go back into our equation, like last one, we want to see where, so we're looking at our asymptote, which is negative 5, and we want to see where our end behavior is. So once again, I'll have a graph so we can look at it so you can see what's going on in the graph. So here is our negative 5 right in here. And here's our asymptote. You can see our graph gets closer and closer to on both sides. So you already know the answer by looking at the graph. As x approaches negative 5 from the negative side, it goes to negative infinity. And as x approaches negative 5 from the positive side, it also goes to negative infinity. So the answer, once again, you're not supposed to graph it on the test. But both of these, as x approaches negative infinity from the left and the right. Yeah, so it's asking it in a little bit different, or it's getting the answers in a different way. It's saying the graph of h approaches negative 8 from the left and the right asymptote. So that's what is happening here. So the left of the asymptote is here, and we're going to negative infinity, and the right of the asymptote is here, and we're going to negative infinity as well. So back to, yeah, so the answer would be this top one. It's going to negative infinity from the left and from the right of the asymptote. But let's look at how we solve it on with graphing. So because negative 6 is a 0, that means that our graph crosses the x-axis at negative 6. So if we were to pick a number that was on this side of negative 6, it would be in positive territory, which would give us a wrong answer. So when we put in numbers back into the equation, we have to pick a number that's after this 0 and before our vertical asymptote, which we can pick any number between negative 6 and negative 5. The issue is just going to be a decimal. I always go with the one right in the middle, which would be negative 5.5. And then on this side, our nearest 0 is at positive 4, which is right here. So we can pick any number between negative 5 and positive 4, including 0. If you want to check, 0 would be probably the easiest number to do. But I always just go one below and one above if possible. One above will give us a 0, so we can't go one above. We have to go half above, or anywhere in between, honestly. So I'm going to pick negative 5.5, and I'm going to pick negative 3 on this side to go back in there. And this, they both should be negative. We've already confirmed that by the graph, but we're going to do it without the graph. So negative 5.5 plus 6 gives us a positive number. And then negative 5.5 minus 4 gives us a negative number. And then negative 5.5 plus 5 is negative. And that's also negative. So if you look at all of this, the bottom becomes positive. Sorry, that's still, the top is still negative. The bottom is positive, which gives us a negative number. So on this side of negative 5, we're going to negative infinity. On this side, negative 3 goes into positive 6, or adds 6, we get a positive number. Negative 3 minus 4, negative number. Negative 3 plus 5 is positive. and also positive. So we end up with a negative number. So we go to negative infinity. So we confirmed what we already knew from the graph. Third question, polynomial over binomial this time, so we don't have to factor the denominator already. And they tell us the asymptote is negative 2, which is true because negative 2 plus 2 would be 0. So I have it completely factored right here for you. So once again, using this cheat sheet, nothing cancels, so we have no discontinuities. We do have two numerators, which means that we have two zeros, one at positive 6 and one at negative 4. And then we have our vertical asymptote at negative 2, which we did already know that. So once again, let's put these in order on the number line. So we have negative 4 is our smallest number. Negative 2 is the number that we really care about. I'm going to box that in. And then positive 6. So once again, we're trying to find a number that's between these two numbers and between these two numbers. Negative 3 is good. I'm going to use 0 this time just because I can. All right, so negative 3 goes in here. Negative 3 minus 6 gives me a negative number. Negative 3 plus 4 gives me a positive number. Negative 3 plus 2 gives me a negative number. So my answer is negative over negative gives me positive infinity is what's happening on this side. On the right side, let's see, we have 0. So 0 minus 6 is negative. 0 plus 4 is positive. And 0 plus 2 is positive. Oops, there you go. And so negative over a positive gives us negative infinity. So let's go look at our answers and see which one is the correct answer. So the graph of P approaches negative infinity from the left and from the right. So from the left side, that's this side, right? We're going to positive infinity. And from the right side, we're going to negative infinity. So graphs approaches negative infinity from the left. That's wrong. Positive infinity and negative. So this is what we want right here. So positive from the left and negative from the right. Okay, so that was the right answer. Let's look at the graph and just see what it would look like on a graph. So once again, our asymptote is negative 2, which is right here. And it's going positive on the left and negative on the right side. So that was also correct. And you can see I graph it both ways. I have the original graph over here, and then I have it factored. They should be the same graph. So if you hide one and expose the other one, you can see how it pops in, and it's the exact same graph. So next question. Okay, polynomial over binomial this time, just like last problem. I have it written right here. Factored. So we have two numerators, but they're both the same. So we have 1, 0 at negative 10. And we have a vertical asymptote at negative 9. All right, so we need to put these in order. So our smallest number is negative 10, and then negative 9, and then that's all we have. So we got to find a number that's between here, which is negative 9.5. A number over here, it could be 8, negative 8, it could be 0. Actually, be positive 8 too. It could be any number this way. I'm going to use 0 again. All right, so negative 5 goes into the problem. Negative 5 plus 10 is positive. Negative 5 plus 10 is positive. Negative 9.5 plus 9 is a negative number. So we get a negative number. So we're going to negative infinity on this side of the graph. On the right side, negative 0. These are all going to be positive. 0 plus 10 is positive, positive, and positive. So we're going to positive infinity on the right side. Let's see which kind of answers they give us. So the left side was negative infinity. Negative infinity left side, and positive infinity on the right side. So B is our answer. Okay, and I have this look at it. So here is negative 9 right here. Left side goes to negative infinity, and the right side goes to positive infinity. So the graph checks out as well. And you can see that they both are true, so I also factored right as well.